Hi, I wanted to do a little bit about something that I was very fortunate to be included in by some friends and fellow hobbyists in 2006. The project was called S.I.S.G, and that is Sidac ignited spark gap, or solid state IGBT Sidac gap. Yeah, I believe that was the acronym. I think that's how it unzipped. Again, I'm going by 9 years ago memories. The boards you're looking at here are 900 volt modules. So each Sidac has a 300 volt breakdown voltage, and so that's 900 each. And then when they break down, this discrete circuitry here, including a couple of diodes and I think transient voltage suppressor, polycap, and potentiometer, which is adjustable too. We could adjust exactly when the gate breaks down, but as soon as it does, then all the peak amperage and 900 volts get switched through the insulated gate bipolar transistor. And then the one in the ones that used in all three of these prototypes you see is the Fairchild 40N120, which it's pretty easy to derive a data sheet. And so, yeah, just used a proto board and crimped and soldered these terminals. And actually, super glue, or no, I didn't use super glue in lieu of thermal glue or paste. I just used JB Weld. And actually, my friend who was a professional power engineer, Terry W. Fritz, who lived in Fort Collins, Colorado at the time, came up with this idea, but I helped prototype this for him. And Terry, Fritz, and Mark Dunn eventually came up with this circuit. This was primarily, if I recall, Terry's design. Let me turn it this way so you can see the credits to the folks that developed this. So the PCB was by Mark R. Dunn. The circuit was by Terry W. Fritz, who incidentally gave me my first oscilloscope a long time ago, probably 2001. It was a Tech 922R rack mount. It developed a horizontal, or actually when he had it, before he sent it to me, it had a horizontal hold problem, and we never really worked that out. I think there was a capacitor somewhere in the CRT circuitry that needed replacement, but he never could track it down himself, and I didn't put that time in myself either because I was too busy working with my own projects. But okay, here we have the finished board, and this is at least a 3600 volt switch, completely solid state, totally silent. And I used this on a Tesla coil with a tank capacitance of 0.15 microfarads. I had two series strings of 0.15 3000 volt Cornell Doublier polycaps, two series strings in parallel. So that gave me about 6000 volts headroom. And I used a single Zebra microwave oven transformer and was able to get thundering, crashing 3 to 4 foot arcs easily out of this coil before it was even tuned. And it was kind of scary because when I turned it up on the Variac, it didn't have linearity. There'd be no output at all until about the 80% point, in which case all 12 of these Sidacs would connect, open all 4 gates of these IGBTs, which were 1200 volt IGBTs. These were the international rectifier, 60B120KD, GPS 60B120KD. So I never even bought the heat sinks. I was gonna scrounge them like I scrounged these. This one, I hacksawed one heat sink in half to cover these two babies, and then just JB welded them on there. And I think I used 21 or 20 gauge enameled magnet wire, or maybe not enameled, I think, for these terminals, and crimped and soldered because we were seeing high peak amperage and high peak current, and I didn't have a current transformer, so I don't have the data, but I'm sure Terry Fritz does. So anyway, that's the data details on that so far. I do have video footage of what I described as far as the running coil, which is on old optical backup. As soon as I recover that, it'll be up here. All right, 73.